So, who remembers what are we talking about as you're getting your things out? Logs, again, logs. So,
Today is your last chance to buy a dance ticket for Midsummer Night's Dream. During lunch, a dance ticket is being sold at lunch.
She looks so
For $8 tonight and tomorrow. See you there. MSA Club will meet today.
Alright, so number one is X's less than or greater than
This
3.
meeting is mandatory students involved in fundraising. Get involved and make a difference. Academic letters are awarded twice a year. Congratulations to all students who earned this honor for their work.
It can be a 3. You can take the square root of 0.
Josh, I feel you. How about that?
That's better? During your lunch period to pick up your report. EMSC will meet this Friday in F216 to discuss upcoming events and the January PBIS lesson. If you are interested in becoming a part of this fun, active group,
are you guys going to be able to see your back is kind of to that? Okay.
For more information.
What about number 3?
Key Club.
Isn't that
All
any number?
trick-or-treat for UNICEF boxes are due now. Bring your boxes to page 206 or to the Thursday Club meeting in the large forum room. Thanks for collecting to eliminate mother and baby pets. Congratulations to the following mustangs.
Try and do as much as you can without the calculator. Try and do as much as you can without the calculator. Use it if you have to, but let's try and do as much as you can without the calculator. Talk to the people in your group.
Please come to the freshman house at the beginning of your lunch period to make a withdrawal from the baby.
I think because
the graphs like this, it goes like that.
I think the domain.
No, it can be
The domain. Yeah, the domain can only be positive, but the range can be all real. That's what it said.
No, the domain can be all real.
I don't know, because the range can be negatives too, because it could be like say log.
You're channeling it? Oh, that's awesome.
Log base 3 of x equals 1/9.
So if you put the 3 in, can you take the square root of 0?
And that would be
Yeah, okay, just checking. All right, just checking. How did I skip
you multiply this.
X cannot equal anything less than 3. X is greater than or equal to 3.
Isn't it X? Isn't it C? Number 5 is C.
I was just explaining.
Okay, awesome.
Oh, I gotta go see.
Find the domain of the function. Okay, I do not. Do you guys understand number 3?
Square root. You can't. It's a square root.
Wow.
So 7. X is so just X is greater than 7. That's it. Oh. There you go. These are good. It's too cool for you. Let me figure out what it is now.
How are we doing? In just a minute, I think some people are still on this screen, so I'll move it up in just a moment.
Yeah, here, let me see. Cal. That would be C.
Okay, I heard somebody say number 3.
It's 0, 1. That makes no sense.
E to the 0 would be what?
When X is 0, Y is 1 for E to the X. Yeah. So then it would be that makes sense. Right, because it's log
Awesome.
If you plug in 0 for so yeah, that would be 6.
E to the 0. So 1 to 5. Yeah.
Okay, 6 would be reals, right?
Yeah. Showing you what here, Maddie. That's good. Then you can go back and review those, right? Good. Okay. How are we doing? Oh, look at you just smoking. Are y'all sharing or y'all just doing your own individual thing? It's all you? It's all you. Of course it is. How are we doing? How do you write that in interval notation?
So 5 is C.
Beautiful. Yep. So practice as much as possible, okay? Interval notation. Nice job. Thank you. Oh, just ignorance. It's just like any other day, really.
All right.
What's that for?
The X point can be anything.
I don't really get.
It looks like she's smart.
It does.
I don't know what the difference is. 2.7.
Yeah, it does have a value, but why are you looking for that? Which one are you working on?
I was just talking about 6. Like, how does E change?
Is that 4 to the 8 or is that 8 to the 4?
I know anything can be an exponent, but I was just wondering if E changes anything, and I guess
No.
A to 1.
So if you were going to graph it, do you have any idea what the graph looks like?
Yeah, I think I know it's like half of a parabola kind of. I just figure out which way it goes.
Okay. Can anybody help him out?
8 is equal to 4 to the 1.
Nick, you said it was all you. So can you, E to the X, what does it look like, the graph?
So you do
Just exponential growth.
Yes, it is.
Normal exponential.
That is correct.
so 3 equals
Okay, does it have a horizontal asymptote?
X, Y,
Yeah.
0.
And Y equals 0, good. Okay, so if you kind of sketch that in your margin, that of what it looks like, it can kind of help you out with the domain,
times
right?
2y.
But it actually crosses the x-axis. Where does it, the y-axis, where does it cross the y-axis?
4 is 0 squared.
0, 1, or 0?
It's 0, 1. And why is it 0, 1?
You raise it to
Yeah, that's
0.
right there.
There you go.
Okay. So then
Good job.
3 equals
Nice job.
2y.
Oh, that means the one thing was not
Divided by 2.
5 and 0, 6.
Y equals 3 halves.
Okay, please take about 4 more minutes to finish up. And then we're going to discuss these. But I'd like for you to do most of the talking. As we roll through these, we're still talking about functions. You were absolutely correct on the entry. We're still talking about functions. So don't forget what's important about functions.
1/5 equals 25, right? 25 what?
Well, 8 is 2 cubes and 4 is 2 squared.
But you have to change that. So that's minus 1/5
Yeah, I know.
So when does 2 squared? 2 squared
Nice.
to the
To
1.
the third. So then,
Well done.
yeah.
Nice job. Make sure you share with your group, okay? Make sure you guys are sharing.
Yeah. No, because see, it's equal 2 to the third. That's not right. I don't know. What did you do? No, you divide 4 by 2.
And why are you choosing?
Yeah.
Sorry. You want to get that 8
And then you get negative 1/2. Yeah. There you go.
Nice job. And can we do math and pencil, please? Thank you, dear.
Okay, so it'd be 5 times negative 2x, right?
X equals 40. Log 25 1/5.
Yeah.
25. Oh,
No, I think I had it right.
yeah, you did. I messed
Wait,
up.
it's not
I was
negative
the one who
2?
messed up, yeah.
Wait, why would it not be negative 2 though?
Because the 25 comes. So it's 25 to x power equals 1/5.
5 to the
So
negative
it's
first.
So negative 1.
5 to the 2x equals.
Negative 2x equals negative 1. No, it'd just be positive 1/2.
Oh,
Because
yeah.
1/5 simplifies to 5 to the negative first, and then
Yeah, 'cause they don't have the
and
same
then you do
base.
5 squared would be oh wait, no, wait, never mind, it's just 2x, yeah, because I forgot, I was changing it to 1/5. Whoops, my bad. Okay, yeah, so it's negative 1/2 then.
How are we doing, Harry?
Pretty well, pretty well.
Okay.
So for this question,
Yes, dear.
it'd just be 2x minus 2. Then you rewrite this 2 to the third.
Beautiful. So your bases are the same. Nice job.
So then you just go set these equal to each other.
Yes.
And these multiplies will be negative 3x.
Beautiful.
Right? You go probably. I would probably just go negative, just subtract 3, and then just divide it and isolate actually to be 1/2, right?
Outstanding. 100%. Well done. Can you share with your group, please?
Yeah.
And make sure everybody's on the same page. Oh, nice. You even restricted the domain. That's impressive. Can you take the log of 0?
I don't think so, no.
Okay. All right. All right. So if you graph it, what do you think that is that's there? The reason why you can't do it. What do you think is there? That is correct. Okay. All right. Yeah, you do. Nice. Okay, is it horizontal or vertical?
Horizontal.
Let's see.
Which question is that you talking about?
Is what? Yes, it is. Nice job. Okay. Nice job. Yep. And you want to be familiar with that, right? Now, if that is the home base, what happens if I had put in x minus 1? Which way does the graph move?
x minus 1.
as my argument instead of just the log of x. What if I put log of x minus 1? Which way is it?
Alright, so that would be
That is correct. Good. Does that sound familiar? Looks like something we've done before, right?
Yeah, because like, I can do all of these, but then like with the transformations of the graph, I'm still looking at the graph.
Exactly. So transformations, and that's exactly what we're doing. So it follows everything that we did with the higher order polynomials before. So the minus means you go to the right, and if it was positive or plus, you would go. That's exactly right. If it was outside, it would be up or down. Right? Nice job. Good. Good, good, good.
We only have 12 problems.
Yes. Is that enough? You want more? I have more. There's more where they came from. I know, you're like, I'm done. Let's go. All right. So how are we doing? What number are we on? The last one? Okay, how are we doing? Are we ready to start discussing? Okay, before we start discussing, listen up very carefully. Somebody in each group should be able to answer a question. Are you ready? So when we talk about functions, how do we know that something is a function? Okay?
Passes the vertical line test.
It passes the vertical line test. That's if we're looking at it graphically. That is correct. It passes the vertical line test. And so when we're talking about functions, they pass the vertical line test. What else do we know about functions? Remember we talked about rational functions in the last chapter, correct? Okay, so what are some things that all of a sudden started to show up in rational functions that we hadn't necessarily seen before? In a regular old y equals x squared polynomial, yeah.
Asymptotes.
Asymptotes, right? Okay, so was there anything in the exercises that reminded you of an asymptote?
Yes.
If I can just roll back to the beginning.
Number 2.
What number?
2.
Number 2. Number 2. Sarnath, help us out. Where is the asymptote and what kind is it?
It's a vertical asymptote at x equals 3.
At x equals 3. Very good. Okay, so how many of you remember that we've done this before? Okay, are you able to make the connection? Okay, that makes sense? All right, so let's go back to this word right here, domain. Okay, which values are those? Okay?
X values.
The x values, very good. So domain are the x values. So Maddie, can you help us out? So when we talk about the domain of this function, what would be the domain?
The domain is x is greater than or equal to 3.
Greater than or equal to 3. So, very good. So if we were to plug in a 3, what do we get under the radical?
0.
0. What's the square root of 0?
0.
0. Who gets it? Okay, so as I walked around, some of you had that x was greater than 3. What'd you leave off? The equal to, because we can take the square root of 0, correct? Okay, good. So it would be greater than or equal to 0. Okay, nice job. Okay, let's drop down to this one. Did anybody look at that graph? Nope. I noticed I didn't see a whole lot of calculators. That was good, because at least you tried it first, right? Okay, but let's see what you came up with for the domain. Which way is this graph moving?
To the right 7.
To the right 7, that is correct. So if it's moving to the right 7, what do you think is the domain? Stephanie, was that an aha moment?
Yeah.
Okay.
So it would be x is greater than or equal to 7?
X is greater than or equal to 7. So what happens if we plug in 7? What do we get?
0.
Can you take the square root of 0?
If you look at the
Can you cube it?
Yeah.
What do you get? No matter what, right?
Yeah.
So the domain would be x is greater than or equal to 0. I'd like for you to please plug that into your graphing calculator and just look at the graph. Okay?
It's like half a.
And as you are doing that, we're going to then progress on to these natural logs, or to the e to the x's.
Line then?
That's kind of bogus.
Because the asymptote's at 7, and it can't be negative, because if you take the square root of something, you can't get a negative answer.
I hear you, IB. You're exactly right. I hear your conversation. Yes?
Oh, I was wondering if we can answer number 4.
If you could do what?
If I could answer number 4.
Absolutely. As soon as we get there. Okay? How many of you were able to plug that graph in successfully? X minus 7 to the 3/2? Okay, did you notice that it starts where on the x-axis?
At 7.
It starts at 7. Does that make sense? What happens if you look at the table of values? Can we get negative values in there?
Nope.
Can we get anything less than 7?
No.
No. Tell me what that means to you. Why can't we get anything less than 7? Okay?
You can't have a square root of a negative number.
Katie's right. Can't take square root of a negative number. Is everybody good?
Yes.
Make sense? Okay. Mr. Castleman, is everything okay? All right. You're not playing games on that calculator, are you? Okay, just checking. You're just punching away. Just checking. All right, good job. Okay, so let's talk about e to the x plus 5. Okay, Vishnu, you wanted to talk. Go ahead.
To find the y intercept of the graph, you plug in 0 for x, and anything to the power of 0 is 1. So 1 plus 5 would be 6. So it would be 0, 6.
That is correct. Okay, good. Number 5. Which of the following expressions is equivalent to that? Where does that come from? Okay, go ahead. C. She says C, Charlie. Who agrees? One of the rules, right? One of the rules for exponents, right? Straight from the rule book. You agree? Mm-hmm. All right, good. So that's one that you really need to commit to memory, right? Because you wouldn't want to have to refer to the book every time, right? Okay, good. What about this one? The domain. There's that word again. Domain, 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 domain. Len, domain. Which values are the domains? Domain is which values? It is all real numbers. But when we talk about domain, what values are we talking about? X values. Good job. So we're talking about the x values. The domain of this function would be all real numbers. She is correct. How do you write that in interval notation? Who wants to talk? Interval notation. Okay, go ahead.
X is an element of parenthesis, negative infinity, comma, infinity, parenthesis.
Nice job. Okay, how are we doing? Is everybody doing okay? Any questions so far? Yes.
When we graph y equals e to the x, there is nothing past negative, like nothing past 0. So wouldn't there be a domain?
There isn't anything past 0. Are you sure? When you say there's nothing past 0, do you mean to the left or to the right?
To the left.
To the left. Really?
Yes.
Okay.
I don't know.
You don't know.
It shows up as error in the graph. So
it does?
I'm confused.
Okay, who can help her out? Okay, Avi, talk. Let's see what happened.
That's true.
No.
Drew, Harry, what happened?
It's basically just on the x-axis, so you can't really see it.
Yeah, what happened? Did you like plug it in wrong?
No, I think I see it now. Okay.
Okay, did you look at your table?
Yeah.
And what happened?
There is stuff past 0.
Oh, okay. Okay. So let's talk about e for a second. Does e have a value?
Yes.
Approximately what?
2.71.
2.71, correct? Mm-hmm. Can we raise that to a negative power?
Yes.
And then we can actually calculate, is it big or small?
Small.
It's small, right? But nevertheless, it's a value. Can you ever get 0? No. So again, we can do it, right? Which is why, like Len said, it goes from negative infinity to infinity. But we have something, because it gets closer and closer to what number as we go farther out to negative infinity? It's getting closer to what value?
0.
0. But it never really reaches it, correct? So that means that we have what there? A Hasse, horizontal asymptote at?
Y equals 0.
Y equals 0. Nice job. Okay, good. All right, can I keep going? We're good? All right, so look at this. What's the y-intercept of the graph? So since you had already graphed it, Katie, talk to us. What's the y-intercept?
The y-intercept is 0, 1.
0, 1 is correct. And do you know how to actually calculate that without the calculator?
Yes.
How?
Because if you put x equals 0, then anything to the 0 is 1. So.
Beautiful. Nice job. Questions so far? Yes. Okay, so let's all right, so let's look at number 8. It happens to be up here. Wow. Because I think there's more than one way to solve that one. How many of you agree? There's more than one way to solve it. Let me guess. Anybody use a calculator?
No.
Nobody? Impressive. Okay, so you all did it algebraically? Awesome. What'd you get for the answer? All together, class?
X equals
3
halves.
3 halves, which is the same as
3 over half.
3 over 2 or 1.5, 1.5. All of that is correct. Good job. Okay, so now let's talk about it. Okay, Vishnu, you want to show us on the board?
Okay.
Okay, so while he's coming to the board to actually write it out algebraically, talk to me for a minute. There's a way to do this in the calculator. Let's say that all of a sudden I said, you know what? Use your calculator. Just all I want to know is what is the value if you were to evaluate that. How'd you do it? What, Stephanie? What?
Well, when you use like the regular log, it's like log base 10.
Yes.
So you have to go into math, and at the very bottom it says log base. So you can, like, if you actually want to use like the log form, you can plug it in as log base 4.
Okay.
8, and then it does it.
Right.
So like that's just one of those features that are in our calculator.
Okay, well here's the deal. If we, let me ask you this. How do we translate this? Because if you just hit the button that's on your calculator, it's understood to be base what?
10.
Base 10. What base is this?
4.
A little bit different, right? So we can't just hit the log button. Yes, what were you going to say?
Well, there's a different way you can do it too.
Okay.
You just have that fraction.
Oh, that fraction. What's that called?
Change of base.
Change of base. It's called change of base, right? So we can change any base that's different from 10 for log, right? By using the change of base formula. So this will be equivalent to what?
Oh, you're joking, man. How'd you do that?
Beautiful. Rada's right. Log of 8 divided by log of 4. Okay? So in your graphing calculators, please do that now. Hit your log button. And it is understood to be base 10, correct? So log of 8 divided by log of 4. Surprise, surprise. Let's look over here and see what Vishnu did. Did you guys get 1.5?
Yeah.
Yeah.
Beautiful. Okay, so what Vishnu did was he said, okay, what I need to do is get my bases of my exponents to be the same, correct? So he said in order to do that, what he said was, I'm going to make my bases the same by having a base of 2. So 4 can be rewritten as 2 squared. 8 can be rewritten as 2 cubed. We have a rule which says, what do you do with this 2 and this x?
Multiply.
Multiply them. Very good. So if the bases are the same, how do you solve for x?
Cut them equal.
Set the powers or the exponents equal to each other, which is exactly what he did. And then he divided both sides by 2, and he was left with x equals 3/2. Nice done. Nice job. Well done. Any questions? So far, so good? Okay, so now you also know how to do that exact same thing using change of base. Is everybody good? Make sense? Okay, good. All right, so let's keep going. So we have just a couple more. So on number 9, we have log, what's the base of that log?
25.
Log base 25. We could use change of base again, correct? But oh no, we're not going to do that because we're going to solve it algebraically, aren't we? Of course. All right, so if we rewrite that as an exponent, how do you do that? How do you rewrite it as an exponent?
25 to the power of x equals 1/5.
Beautiful. 25 to the power of x equals 1/5, right? So 25 to the power of x equals 1/5. We have a problem, Houston, don't we? Don't the bases need to be the same? So how do you make 25 and 5 the same? What'd you do?
25 is the same as 5 squared.
Outstanding.
So I put that in the exponent.
Okay.
And 1/5 is the same as 5 to the negative first.
It is. Nice job. How many of you rewrote it that way? Okay, that's exactly what you should have done, okay? And I saw a couple of you making some changes. That's good, because that's the way you can go back and review later, right? So she's absolutely correct. Keep going for me. So you ended up with 5 to the... I'm sorry?
5 squared.
Yes.
All to the power of x equals 5 to the negative first. Which you can rewrite as 5 to the power of 2x equals 5 to the negative first.
Okay.
And if you set the exponents equal to each other, you get 2x equals negative 1. When you divide both sides by 2, you get x equals negative 1/2.
Outstanding, right? Just checking. All right. Well done. All right, so now here's one. Oh, all of a sudden we have an expression or an equation to solve. Right? We have an equation to solve. We're still doing logs. We're still doing exponents. We're still looking at graphs. We're still solving, right? Because we can solve them algebraically. We can solve this one graphically. How many of you agree? Can we solve this graphically? How? How can we solve this graphically? I didn't ask you to. I just said to solve it. So you can do it a variety of ways, correct? You can do it algebraically, like what Vishnu did here. You could, but I want to talk about a different way to solve this exact same problem. Okay, talk to me. Sorry.
Could you subtract 4 from both sides? So you have log base 3 to 2x minus 1 minus 4 is equal to like x or like y. So could you put that in everything?
And then do what? And what are you looking for?
The
You just put it in and that's it?
would be when like we crossing the y in No, I don't know.
Okay, talk to us.
I would do it differently. I would do 3 to the 4th. I would graph 3 to the 4th, and I would graph 2x minus 1 and look for the intersection.
Oh my goodness. Look at that. He would rewrite it as an exponent. 3 to the 4th, isn't that what Vishnu did over here? 3 to the 4th equals the argument. And he's looking for a point of intersection in the graph. That's exactly right. And what were you going to say? There's yet another way. Go ahead.
I did the change of bases on one side. And then
wait a minute. Stop. Okay, go ahead.
I did the change of bases on one side and then the graph of y equals 4 on the other, on another equation, and then I saw where they intersected.
That's exactly right. That also works. He could have used change of base. Log of 2x minus 1 over log of 3 equals 4. And look for a point of intersection. All of that is still going to yield you the correct answer. How many of you understand? So you have choices, right? Which is why I said here to explain your answer, because there's a variety of ways to do it. Some of you, as I was walking through, had done it in a variety of ways, and then you were arguing, but you were saying the same thing. No, this is how you do it. No, that's how you do it. And you were both correct. Now you understand why? Yeah. Okay, so that's why we needed to clarify, because I don't want any fights to break out. We're all good? We're all friends? All right, good. All right, nice job, Harry. Okay, so let's look at this. What's the domain? The domain. There's that word again, Lynn. What's the domain of log of x? Yes.
Isn't x is greater than 0?
X is greater than 0. Can it be equal to 0?
No.
Why not? Wait. Let's go to Madhav. Why can't it be 0?
Because when you rearrange it, whatever x is what the whole equation equals, but a number to the power of another number can never be 0. If the power of the number is 0, it would be 1, and if it's negative, it gets infinitely close to 0.
Well said. Nice job. How are we doing? Does everybody understand that? Another way to say what he just said was rewrite it the way that Vishnu did as a power, right? What's the base understood to be if we don't see it? 10. So 10 to the y equals x. Can it ever be 0?
No.
That's exactly right. That's why the domain is greater than 0. Make sense? Because we can't take the log of a negative number, can we? Okay, good job. All right, questions? Nice job, guys. Okay, so now let's take some bumps out of logs. You ready? Let's take some bumps out of logs.
I love that joke.
Okay. No, literally. Look at that. Let's remove some bumps from logs. Isn't it special? I know, right? So let's remove some bumps from logs. I have here, I would like for you to work as quickly as possible. Because either you know or you don't, right? You're going to talk to the people in your group. You're going to argue, but not fight over these problems. Okay? I did leave a space in the middle of the floor, though, just in case a fight needs to break out. Okay? So what I'd like for you guys to do is to solve these problems as quickly as possible. If it asks for an explanation, I need a mathematical explanation. Are we clear? Don't forget that we're still talking about functions, domains, and ranges. We're still discussing intercepts, x and y. We're still solving expressions. We're rewriting exponents as logs and logs as exponents.
Yeah. And vice versa.
Interesting. Hey, did everyone get a copy?
Wherever you act.
Would you like a copy?
Every input has exactly one output.
Yeah, so you just switch.
Right. Wait a minute. Hold on. It better be done.
I'm starting to remember.
This is good. This is good.
X squared, yeah.
It does.
If x is greater than or equal to 0, yes, it does.
Yeah, because then you get just half the graph.
Yeah.
Don't forget your properties of logs, your properties of exponents, they do still apply. The domains and the ranges are still important.
Oh, we're going to the right.
Make sure you talk to the people in your group.
Have an inverse.
I would like for you to continue to stick with the problem until you figure it out. Don't give up. And we do math and pencil, right? I'm just saying, fix that. We do math and pencil because we all make mistakes.
Then you only have the positive part of the graph if it's greater than or equals 0. So for every line you drew through, you'd only have one.
Because there isn't something like that.
It passes the horizontal line test, right?
There you go. Nice job, guys. Very good. Very good. And thank you for using complete sentences. That's awesome.
which is correct and why. AS times 18.
Yeah, because how would you want to explain it? Just say like this is
like common base means add exponent.
Mm-hmm. It's one of the rules, right?
Yeah.
Good. Very good.
Alright, so now compare the contrast. Oh, the negative x flips it.
The sentence doesn't make any sense.
So tell me what you're trying to say.
If they have a common base and you're multiplying, you add the exponent.
That is correct. Now, all you had to do was write that. I'm just saying. You can go on to the next one, but you're right. Okay? Good job.
Okay.
Is
y to the negative?
Square root, and that's not x. So that the square root of x is equal to y. So there's no inverse because it doesn't equal x. For this one. You should just do the easier one.
Oh, well, wait. Let's look at what she has. How many solutions should we have? That's exactly right. So you'll get a plus or minus. Does that make sense? So you're on the right track of the way you were thinking about it. But you can only, but remember, you're only supposed to get how many answers?
Why not?
One. That way you're getting how many? That's right.
When x is
Makes
greater
sense?
than or
So
equal
the way that you were thinking about
Take
it.
out the negatives.
when x is greater than
There you go.
0, yeah.
That's exactly right. Nice job, Sophie. Well done. Okay.
Because it's one of the, yeah.
Did you write yeah?
The function.
Oh, Ben. Oh, Ben. I need you to come before school. We're going to have an English session, okay?
I just wrote a long English paper. That's why I'm
Right.
ready to write some more.
You plus right in you know?
Yeah, I got an English paragraph.
Are you sharing with your group? Are you coming up with your answers, or are you just working your worksheets?
Yeah, and then when it's negative in front of the whole thing.
I would like for you to collaborate where possible. Please share your wealth of knowledge.
B is correct.
Okay, what does that mean?
It does not take
That is correct. Okay, so that would I would appreciate a full sentence, but you know, just so you know. Okay. Nope.
Isn't it just the domain? So it just can't go off?
Oh,
it has to be greater than
greater than 0.
Greater than 1. Yeah, it has to be greater than 1.
Ignore the log one. You just do the x.
And why is that?
Because like you cannot x cannot equal 0. So it's like you cannot like if you raise it to any power you'll never get 0 or something.
Okay.
If it's
good.
less than 1, it's negative.
Okay, that's exactly right. So it has to be greater than.
Yeah.
Nice job. Well done. Okay. And just make sure you remember that, because again, whenever you're doing the argument for the logs, you can't have negative and you can't have 0. So if you're in a situation like this, even though algebraically it works out to give you those values, right? You have to think within the context of the problem what actually makes sense. That makes sense? So when we start talking about flu viruses spreading, you know it can't spread negatively.
Yeah.
You with me? Yeah. Okay.
So information you need to
No, it's not. Yes, it is.
Oh, done. Look at you. Just
I
flying.
have a quick question.
Okay, hit me with a quick question.
Okay, so when you do natural logs and just regular logs, is there a difference in the way that you find all of these things, or no?
No.
Okay. So it's the same thing?
Yes.
So then what's like the main difference between like, I know like the natural log has like the E in it. Is that like the only like?
That is correct. The base is E for that and the base is 10 for the other one.
Okay.
That is the only difference.
Okay.
Yep.
All right. So, but so you would solve it like the same way as if this were just like a log?
That is correct.
Okay, thank
Yes, absolutely. And which way did that graph move, by the way?
you. Wait, to the right one?
To the right one. And what did
Flipped
that
over
do?
the X.
Flipped over the X. All right. All right, just checking.
Stephanie, for this, what did you get? X cannot equal 1. Number 7.
Yes.
Okay, for these, is it up to the x?
Yes, 2 to the X equals 1.
Okay.
So what value could you plug in here so that you get 1? Anything to the what power?
0.
There you go.
Okay.
Okay.
Yes.
Okay, now this one, you technically have, how do you rewrite square root
Probably just
as an
that.
exponent?
I don't know.
Squared.
I'll come back to that one.
Right?
Squared?
Well, that's to get rid of it. I'm not sure.
Okay. Think about it. Think about it. Is it going to be a whole number? Or is it going to be a fraction?
It'll be a fraction.
What does square root mean? To the what power?
To the, no, not to the half.
Yes.
Okay.
Yes. That's it. So rewrite that as 3 to the 1/2 x.
Oh, okay.
Okay, equals 9, right? Now, if we wanted both of these bases to be the same, what base could we come up with over here that matches that one?
3.
3, right. So 9 is the same as 3 what?
Squared.
Exactly. So now look, your bases are the same, so what do you do with the powers?
Whatever it's called.
Set them equal to each other?
Yes.
Is that the word?
Yes.
Is that the word?
Is that the word?
Yes.
I was looking for the verb. So what's x?
Is this right?
1.
Number 9 is tripping me up a little bit.
Same.
1, right?
Would
Nope.
you do it like this? Negative.
So you have 2
y
divided by
equals x
1/2.
minus 1.
Oh.
Not 2 divided by 2.
Would you write it out like this? Negative e to the y.
Yes.
Yeah.
I'm not sure.
Nice job. See? See what happens? You stuck with it? You got it, right?
Yep.
Now you'll remember it because you left the paper trail also, right?
Yes.
So you can see what you did to do it. Now, if you throw this piece of paper away and put it back, are you going to be able to know what you did, what order you were going in? You need to leave a trail,
Okay.
right? Do some arrows or something
Trail
so you can
of
follow it,
tears.
right? There's no trail of tears.
That's
Oh,
math.
no. Oh,
Wait,
no.
Miss Johnson, can you take a natural log of a negative number?
I don't know. Can you? How could you figure that out?
Well, you can't, right? Because nothing will ever, to any power, will equal 0. So even like e. So then, like, this would be x is greater than 1. But
That
it
is
can't equal 1.
That is correct.
Got it. Oh,
Nice.
I get it. I get
Nice.
It.
Okay, now explain this one. X value, not as
Yes, dear.
So it's
Okay. So,
oh wait, never mind.
Okay.
So vertical asymptote. The horizontal asymptote is the same. I was thinking horizontal.
Yeah.
Yeah. This is true.
Vertical is, yeah, so.
But wouldn't it have a horizontal asymptote if it was only negative numbers?
Yes, that is correct. Good job.
We're allowed to use our calculators.
It appears that most of you are about done. Yes, sir. We're
Which
gonna
one
go
was
over these
natural
so we can
log?
talk about
Here
it.
we go.
Oh, here, we can do number 10 real quick.
Here, do you want me to work on this one? You can work on that one.
Here, I'll do 10 because this one's easy.
Oh, Lordy. Okay, that's kind of weird.
Get a syntax.
No. Wait, there's an error when x is 0.
Yeah.
So there is no. Oh.
So there is a horizontal asymptote. There is a vertical asymptote.
Oh, I was talking about the intercepts.
Oh, the intercepts. So there is no
Y-intercept. Yeah.
Wait, why is there a...
Because there's because x cannot equal 0.
Because we moved it over...
Yeah, and the domain.
Gotcha.
Yeah.
Can you explain number 10 to me? Okay, so what they did basically was they said 2 to the 3rd times natural log of 8 is equal to the natural log of 8 to the 2/3, which is incorrect. Right? What would that be?
True, like when you have something like this, you have a log. You have to divide it if it's negative, and then.
Well, that's not the error they made.
How are we doing?
Well, the right side of the equation is fine.
Did you find a mistake?
Okay, this is. Okay, this is all right.
It's all right?
Oh, but that. Yeah. I mean, if you subtract, then.
Make sure you discuss. Make sure you discuss.
Okay. No, I'm pretty sure you divide it when there's a
Inside natural.
Okay, just a couple more minutes, please, because we need to start talking about these. I would love to hear your conversations, right? Some of you were saying some things. Harry, you have a question?
No, it's the same.
Okay, some of you were saying some things as I was walking around that I want to make a clarification about. Specifically, range is which values again?
This is the same as this. Like
the y value, so you must remember that.
Yeah, that's right.
Graphically, I found out the range to be like E. Yeah, is less than E or less than or equal to E, right? Can it be less than E? But I don't know how you'd figure that out algebraically.
I don't know. What's the base?
The base of this? Isn't that E?
It is E. Remember, whenever you have natural log, base is E. So how can you rewrite it as an exponent? E to the.
So it would be E to the. Well, it would be e to the y.
Yes.
Equals x minus 1.
Right. So that should help you out. That's all I gotta say.
Right, thank you.
That's all I can do. The rest of it I want you to figure it out, right?
And then it's approaching y equals 3, so it'll never get close. It'll never reach.
Yeah, because remember there's that whole rule, like if you put a coefficient in front of logs, it's the
power.
Yeah.
It's the power?
Yeah.
Okay.
Yeah, there was that whole rule we did last year.
Okay, that makes sense.
Okay, please pause where you are. I know you want to finish. I know you can't wait to finish, but please pause. Can I get your attention, please? Ladies
I put
and
this entire
gentlemen, can I get your
equation
attention?
in there equals 0.
Okay. I would like for you to finish it up for homework, those of you that didn't finish, especially that one that has the range problem, right? I would like for you to figure it out because I know you can. Okay? I would like for you to just dwell on it a little bit longer. Okay? And that will be the first thing that we tackle on Monday morning, right? The range for that one that everybody got stuck on. Okay? Because I know you can figure it out. I'm not going to tell you. But think about it. I know, yeah, you got it. But what I'd like for you to do is to think about it in terms of how can I rewrite it as an exponent, right? And then if I were to graph it, how do I determine the range? Got it? So you're going to figure it out, and then we'll be able to discuss it. What I'd like to do first is shift gears a little bit, and then we're going to talk about these problems. What are some real-life ways that we can use exponents? Anybody? Exponents. What are some real-life applications for exponents? Okay, Abby.
Like exponential growth and stuff.
Exponential growth. And what's the opposite of that? Decay. If this was your money we were talking about, which one would you prefer?
Growth.
Okay, just checking. Just checking. Okay, so which one grows faster? Linear or exponential?
Exponential.
Exponential. So if this were your stock portfolio, which one would you prefer to have model your money?
Exponential.
If you were taking a loan out from the bank, which interest rate would you prefer? I like that. Exponential decay. I like that. Okay, so we were comparing linear to exponential. Which one would you would prefer linear? Okay, good. Just making sure. That was good. That was good. Okay, so we can solve equations, obviously, correct? We can solve equations. We can rewrite logs as exponents. We can rewrite exponents as logs. We can still find domains and ranges. We're still talking about functions, right? Still talking about functions. We can do inverses. We did that on yesterday, correct? So do you see the connection between the functions that we talked about in the last chapter to the functions that we're talking about in this chapter? What are some things that are similar or exactly the same as we talked about in the last chapter that we're still doing with the exponents? Yes?
Well, we still have discontinuities in our graphs.
We still could have discontinuities. What else? What kind of discontinuities?
Vertical and horizontal asymptotes.
Vertical and horizontal asymptotes. It totally depends on how the equation is written, correct? Got it? Okay. Real life. Let's go back to again. So we're talking about exponential growth or exponential decay. What are some real life math models where we might do a regression analysis? Because that's something else that we've done before, right? Regression analysis. Remember those? In the past, we were looking at linear regressions. What's another type of regression? Quadratic regressions. We were looking at those to model data. Where if we're talking about your interest rates, or if we're talking about a flu virus spreading, we would do exponential regression models. Because normally what happens to a flu virus? Does it decay quickly or does it spread quickly? It spreads quickly. Is everybody with me? See where this is going? Does that make sense? All right. So will it ever trickle down to zero? Probably not, right? Which is why some of these diseases are all of a sudden starting to resurface again because we didn't totally get rid of it. Does that make sense? Even though we, had immunizations, they stopped doing some of the immunizations and then of course the diseases started to spread again. You with me? And spread quickly. All right, nice job. So now I want to go to some of these explain ones, like number 3 and 4. It says, does y equals x squared have an inverse? If something has an inverse, first of all, what does it mean? It has to pass the horizontal line test. I heard somebody in the back say it has, for every x, there's what? There's one y, right? So if it passes the horizontal line test, what about y equals x squared? Why does 3 have an inverse? How many of you say no? Okay, and I saw some of you that said yes initially, but then your group mates persuaded you differently. Okay, what happened? Yes?
Since it's a parabola, it doesn't pass the horizontal line test because everything is squared, so everything's positive.
Doesn't pass the horizontal line test, right? No. What's the difference between 3 and 4? Stephanie?
In number 4, they're only talking about the positive x's, so it's only the right side of the parabola. So it's going to pass the horizontal line test because there's only one x for every one y.
That is correct. Okay, so if we were to graph the original f of x in the same coordinate plane as its inverse, what should you expect to see if they are true inverses? What should you expect to see in the graph, Radha?
It would reflect over the line y equals x.
It will reflect over the line y equals x. How many of you agree? She's 100% correct. What if I just did coordinate points? How could I graph the inverse if I only knew coordinate points? Joe.
Switch the domain and range.
That's exactly right. Switch the domains and the ranges, correct? Which is exactly what we do if we solve them algebraically. Does that make sense? Everybody's good? If we look for inverses algebraically, we will switch the x's and the y's and solve for the new y's. Good job. Okay, so compare and contrast. For those of you that say, I prefer English over math, I want to appeal to you. Compare and contrast 2 to the x and 2 to the negative x. Where are my English people? Fess up. Now nobody wants to be English, right? Compare and contrast. That means you're talking about similarities and what else? Differences. Yep. Who wants to talk? Okay, talk to us.
Well, for similarities, the y values are positive for both graphs.
Okay, he said the y values are positive for both graphs. How many of you agree? Okay, keep going.
Yeah. And then they're symmetrical over the y-axis.
They're symmetrical over the y-axis. When you say they are, what do you mean? If you graph them both?
Both
or?
graphs, yeah, because you take the x's negative, so like one of the transformations would be that it's just flipped over the y-axis.
Oh, okay, so he's saying that they're reflected, not flipped. Reflected, over the y-axis, correct? So reflected over the y-axis. Good job. Okay? So reflected over the y-axis. One of them is growth and the other one's decay. Isn't that right?
Yeah.
Okay? Again, we're talking about your money. Which one do you want?
Growth.
Which one do you want?
Growth. 2x.
2 to the x, right? Oh, somebody wants 2x? Who wants that? Okay, fess up. It's okay. All right, good job. Okay, let's keep going. All right, so now I want to touch on a couple more. So for this one, a student did this. Did anybody find a mistake? Oh, look at that. Because as I was going through, some of you were like, there's no mistake. I said, really? Did you talk about it? Did you work it through? Because I think there is. I think. I think. Do you think? What do you think, Sergio? You think there's a mistake?
Yeah.
Really?
Try with that one too.
Oh, can you talk to us?
First of all, 3 to the
Huh?
4th is not 12.
What do you think happened? What did the student do wrong? Okay, everybody listen. Let me blow it up first, Sergio. Okay, let me blow it up so everybody can see it. Okay, so we're talking about this one. So Sergio says, oh yeah, there is a mistake. What'd they do?
For the ln parentheses 3 to the 4th minus 8, he put that 3 to the 4th was equal to 12.
Stop right there. Hold on. Oh, don't laugh. Don't laugh, because some of y'all did the same thing. Those of you who said, there's no mistake. 3 to the 4th is not 12. Didn't I tell y'all to practice y'all math facts? 3 times 3 times 3 times 3? Is that 12? What is it? 81. Okay?
Is that it?
So, now that we found the mistake, how many of you can finish it? Raise your hand. Can you finish it? Okay, you got 30 seconds. 25.
20.
20. You got it? Up.
You can do that, right?
Go ahead and finish it. Go ahead and finish it.
It's not natural log.
Finish it. So tell us, what happens when we divide? How do we continue?
How did you get? How did
Come on, you can do it. You can do it.
natural log?
Keep going. Yeah. Yeah. So what is it?
We dividing natural log of. Oh, I don't know which number to say first. 73 by natural log. No, wrong way. Natural log of 4 divided by natural log of 73.
Oh, not quite. Almost.
Why?
What's the rule? Look it up. Look it up. Look in those books. Don't forget your book is a resource. Your book is a resource. If you forgot that property, look it up.
Property. Where is the property? Darn it, I don't know.
Wait, because when you subtract natural logs.
All right. It appears that most of you have found the property.
Well, because this would be
Where is
easier,
yours?
that if you have, like,
what is that?
you just plug it in.
What's that say?
This seems so high tech.
Oh, okay. I see. You got okay, so keep going. Yep.
Okay, so then this would be minus natural log of 73. So then wouldn't it be natural log of 4 divided by 73?
Yes. Well done. All right. All right. Good job. Excuse me, we have to finish what we started. Sergio, can you complete the rest of that problem, please? So you started out with 3 to the 4th was 12, right? But we now know that that's not correct. 3 to the 4th is what?
Yeah.
81.
81. Keep going, please.
So 81 minus 8 would be 73.
Okay.
And so then the other half where he put 2 over 3 ln 8, that would turn into ln 8 to the 2 over 3, and that's ln 4 minus ln 73, and that turns into ln 4 over 73.
And that last step, where did that come from? ln of 4 over 73?
Properties.
Log properties. Good job. Question? Anybody? How many of you got it now? Who made your corrections? Tell the truth. Who made your corrections?
I have a question. So is it the natural log of 4 divided by 73?
Yes, it is.
Oh, okay.
All right.
Got it.
But again, use your book. They're not hiding it. It's in there. It's in there on the properties page. All you got to do is look at it. And when you're doing your homework, you will use the properties over and over and over again. And by that repetition, you will be able to commit it to memory. All right? I'm so glad we had this time together.